Welcome to the AI checkpoints. Imagine a world where the AI voice on your phone doesn't just tell you something, but actually, feels it.
Yeah, or an audiobook narrator conveying real empathy or joy makes you forget it's a machine.
Exactly. For years, that's kind of been the holy grail of AI speech synthesis, right?
Definitely.
Today, we're doing a deep dive into what looks like a fascinating breakthrough. It seems to bring us remarkably close to that goal.
Mm-hmm.
We're exploring a recent technical report just came out last month, August 7th, 2025. It's from Alibaba International Digital Commerce.
Right, on their system called CosyVoice.
Yeah, Marco voice. And this isn't just like basic text-to-speech. They're talking about capturing the real essence of a human voice.
All the emotional stuff, the unique identity, the whole package.
So our mission today is really to unpack this research, understand the really deep challenges it's trying to solve.
And see how CosyVoice actually aims to create this genuinely human-like synthetic speech.
Okay, so where do we start? I mean, why has truly human-like speech been so hard for AI?
Well, it's a huge leap they're trying to make, because even with all the progress we've seen lately, getting that truly human quality, it's remained a massive open challenge.
Right.
Just think about our own voices. There's your unique identity, the researchers call it timbre, right?
Uh-huh. The sound of you.
Exactly. Then there's the rhythm, the intonation, the prosody.
How you say things.
Yeah, the melody of your speech. And then you layer on that incredibly rich tapestry of emotional expression.
Getting an AI to nail all three at once.
Without sounding robotic
Yeah.
or just plain weird.
Yeah.
That's been incredibly difficult.
So, okay, if that's the big picture goal,
Yeah.
what specific problems were holding AI back? What hurdles does this Marco voice paper really highlight?
What's really interesting is how clearly the CosyVoice team lays out these persistent fundamental challenges.
Okay.
First, they talk about the entanglement of timbre and speaking style.
Entanglement, meaning they get mixed up.
Exactly. Many existing TTS models, they sort of jumble a speaker's unique voice, that core sound, with their specific manner of speaking at that moment. Maybe their emotion or just their style.
Okay. So it makes it hard to, say, clone my voice.
But then have your voice express, I don't know, sadness if the original sample wasn't sad.
Right. It wouldn't sound like me being sad, maybe.
Precisely. Or it just sounds unnatural. You lose that distinct character, or the style feels forced. The who and the how get stuck together.
Okay, that makes sense. Challenge number one, what's next?
That entanglement leads right into the second challenge. Balancing prosody and emotion consistency.
So the rhythm and the feeling have to match up.
Yeah, and it's really tricky to get both right simultaneously. Older systems, they often leaned one way or the other.
Like good rhythm, but flat emotion.
Or maybe it sounded emotional, but the rhythm and intonation were all over the place, totally unnatural.
Gotcha. Like hearing someone sound really angry, but speaking in a super slow, calm rhythm. It just doesn't compute.
Exactly. It breaks that illusion of authentic speech instantly.
Okay, so entanglement and then balancing rhythm and emotion. What was the third big one? It was about emotion itself, wasn't it?
Yeah, the limitations of conventional emotion modeling. Most AI systems have relied on these very discrete, almost like buckets of emotion. Happy, sad, angry.
Like basic categories.
Right. But human emotion isn't like that, is it? It's a spectrum. It's continuous, it's nuanced.
You're not just happy. You could be, I don't know, amused, ecstatic, content.
Exactly. Capturing that subtlety, that continuous flow, that's hard with just a few labels. Plus, there's the challenge of keeping the speaker's identity intact when you do add emotion, especially in voice cloning.
So even if you could make my voice sound sad, it might stop sounding like my voice.
That's been a huge hurdle. The emotion kind of washes out the identity.
Wow, okay. 3 big challenges. And you mentioned they pointed out a fourth one, too. Yeah. Something about the data.
Absolutely. That's like a foundational issue. A major limitation across the board has been the sheer lack of high-quality emotional speech data.
Right. You need lots of examples to train these things.
And not just lots, but diverse, well-labeled data showing different emotions by different speakers. Especially for languages other than English, that's been a real bottleneck.
So quite a few complex problems to solve. How does Marco Voice try to tackle all of this? The paper mentions a unified system. What does that actually mean in practice? How's that different?
Well, it raises that important question. Why did previous systems struggle? Often they used separate parts, separate modules, one bit for the speaker's voice, another bit for the emotion.
Like building with separate Lego blocks.
Kind of. And while that might seem simpler to build, the Marco Voice team argues it leads to weak connections between those parts. The interaction between speaker identity and emotion just wasn't being learned properly.
So the blocks didn't quite fit together smoothly.
You could say that. It often resulted in that unnatural blend or the speaker identity getting lost when you tried to make it expressive.
Okay.
So, Marco Voice takes a different path. It integrates voice cloning and emotional speech generation within a single unified framework. One system handles it all.
Ah, so it learns everything together.
That's the idea. It allows the model to really learn the subtle, complex interactions between speaker characteristics and emotional expressions simultaneously.
Seeing the voice as a whole, not just parts.
Exactly. Leading to, hopefully, much more natural and consistent speech.
That makes a lot of sense intuitively. Okay, so the paper breaks down their work into two big pieces, right?
Yeah.
The Marco Voice model itself, and then this new data set they created.
Correct.
Let's start with the model. What are the core innovations inside Marco Voice that enable this unified approach? What makes it tick?
Okay, so the model itself has several key mechanisms designed to hit those challenges we talked about head on.
Right.
First, and this is really crucial, they developed a sophisticated speaker emotion disentanglement mechanism.
Disentanglement again, really separating them out.
Properly separating them. Think of it as a highly specialized filter. It isolates the unique speaker identity from the how, the emotional expression within the speech signal itself.
So you can control them independently.
That's the goal. You can clone a voice, capture that unique timbre, and then apply different emotions to it without losing that core identity.
How do they actually achieve that separation?
They use a few techniques, including something clever called in-batch contrastive learning during training.
Contrastive learning. That sounds like it's teaching the AI by showing it examples and non-examples, highlighting differences.
That's the gist of it, yeah. It helps the model learn distinct representations for speaker features versus emotional features, pushing them apart, essentially, making sure they don't get mixed up, even when they appear together in the training data.
Okay, clever. What else is new in the model?
Then there's the rotational emotion embedding integration.
Rotational embedding.
Oh.
Okay, what does that do?
This is how they tackle the discrete categories problem for emotion. Instead of just happy or sad labels,
Right, the buckets.
they represent emotions in a continuous space. Imagine a circle with neutral at the center. Other emotions are represented by their angle, their rotation away from neutral.
Oh, interesting. Like a dial for emotion instead of just switches.
Exactly. That's a great analogy. It allows for much smoother control over emotional intensity and maybe even blending emotions, capturing that continuous spectrum we talked about, much finer grained control.
Very cool. So disentanglement, rotational emotions. What's the third piece?
The third key innovation is a cross-attention mechanism.
Cross-attention. That
Yeah.
sounds like it connects different parts.
Precisely. Think of it like a conductor ensuring the different sections of an orchestra are playing together with the right feeling. This mechanism weaves the emotional information from the rotational embeddings directly into the linguistic content, the words, as the speech is being generated.
So it's not just layered on top at the end.
No, it influences how the words are actually formed and spoken from the start. It ensures the emotion is integral to the speech, not just an afterthought. Makes the whole delivery much more cohesive and natural.
Wow, that sounds like a really integrated, thoughtful design. But you need data to train such a complex model, right? Especially good emotional data, which you said was scarce.
Absolutely. And that's where the second major contribution comes in. They built their own data set.
Called Cease Emotions.
Yep, Cease Emotions. To properly train and evaluate Marco Voice, they constructed this high-quality emotional speech data set.
What's in it?
It's about 10 hours of Mandarin speech. Crucially, it's from 6 professional native speakers, 3 male, 3 female, all with extensive voice acting experience.
Ah, so people who can genuinely portray emotions consistently.
Exactly, that's vital. It covers 7 distinct emotional categories. And importantly, all recordings were done in professional studios.
High quality audio.
Very high quality, yes. And consistent emotional expression. They also created a set of 100 evaluation prompts for each emotion in both English and Chinese for standardized testing later on.
Okay, so they built the tools and the fuel, a new model architecture, and a dedicated data set.
Pretty comprehensive.
So the big question then, does it actually work? How does it sound? They must have done extensive tests. What were the key findings?
They definitely put it through its paces. They evaluated Marco Voice on its 2 main jobs, voice cloning, and emotional speech generation.
How did they test?
A mix of things. Lots of human evaluations using those 5-point Likert scales for ratings. How natural does this sound?
Subjective scores.
Right. And also direct A/B preference tests where listeners just pick which one sounds better without knowing which is which. Plus, they used objective metrics for deeper analysis.
Okay, let's break that down. Voice cloning first.
Huh?
How did Marco Voice do against existing systems, like you mentioned CosyVoice 1 and 2?
Well, in the voice cloning tests, Marco Voice consistently came out on top. It outperformed CosyVoice 1 and CosyVoice 2 across pretty much all the important dimensions: clarity, rhythm, naturalness, overall satisfaction.
And the big one, speaker similarity. Does it sound like the original person?
That was a key win. It achieved the highest speaker similarity score, 0.8275. That's a noticeable jump from CosyVoice 1, 0.700, and CosyVoice 2, 0.605.
So, a significant improvement in preserving that unique voice identity.
Definitely. It suggests it really does sound more like you when it clones your voice.
Okay, that's impressive for cloning. What about the emotional side? Did it make voices sound genuinely expressive and convincing?
It did well there, too. Marco Voice also showed the best performance in emotional expression, getting a 4.225 score, and the highest overall satisfaction score at 4.430.
Better than CosyVoice 2 in those aspects.
Yes, surpassing CosyVoice, too. So it indicates that their whole approach about the disentanglement, the rotational embeddings, the cross-attention, it seems to be working in producing more natural and believable emotional speech.
And the ultimate test, maybe? The blind A/B comparisons? What did people actually prefer when they just listened?
The A/B tests really backed up the scores. Listeners consistently preferred Marco Voice. 60% preferred it over CosyVoice 1.
Okay.
And even more convincingly, 65% preferred it over CosyVoice 2.
Wow, almost 2/3 preferred Marco Voice over the more recent CosyVoice system.
Yeah, it strongly suggests that listeners really did perceive and value the improved emotional expressiveness and that better speaker similarity. It just sounded better, more convincing to most people.
Okay, so human listeners liked it more. Did they also look at objective metrics, things computers can measure?
They did. They dug deeper with objective metrics on standard datasets like Liberts for English and Eichel 3 for Mandarin.
What did those show?
Their most advanced version, Marco Voice v4, got the lowest word error rate, or WER, on Liberts 11.4, which is good for clarity while still maintaining that high speaker similarity.
Lower errors means it's saying the words correctly more often.
Exactly. On the Mandarin Eichel dataset, the Marco Voice variants also showed strong speaker similarity and good perceptual quality. Interestingly, they did note some higher error rates there.
Oh, why was that?
Well, they suggested it might actually be because the speech was more natural and emotional. Natural speech often includes, fillers like, or,
The things we actually say.
right, things that aren't usually in the clean text transcript used for calculating where. So paradoxically, a higher error rate in that specific metric might actually reflect more realistic, spontaneous speech.
That's a fascinating point. Sometimes being less perfect according to the metric means being more human.
It can, yeah.
Like, yeah.
Highlights the limitations of purely objective metrics sometimes. But
Yeah.
overall, looking at the progression, Marco Voice v4 consistently achieved the best accuracy for emotion recognition on both the Chinese dataset, a 0.78, and the English 1.77.
So it's good at recognizing and presumably generating the intended emotion.
That's what the results suggest, yeah. Robust across languages, too.
That's really solid performance.
Yeah.
Did they uncover any other, maybe surprising patterns when they were analyzing all this data? Anything that jumped out?
Yeah, a couple interesting things came out of their deeper analysis.
Like what?
Well, looking at cross-lingual emotion recognition, how well emotions were recognized across both Chinese and English, they found neutral and angry emotions were consistently picked up really well. Pretty robust.
Okay, those seem maybe more distinct.
Perhaps. But surprise and sad emotions, those were consistently more challenging to recognize accurately in both languages.
Maybe more subtle cues involved.
Could be. Or more variation in how they're expressed. Interestingly, though, the later versions of Marco Voice, V4 and V5, showed better performance specifically for these trickier emotions, so the model improvements helped there.
Good to see progress on the hard parts. What about audio length? Does it matter how long the clip is for recognizing the emotion?
It definitely does. They looked at the impact of audio duration. Unsurprisingly, really short clips less than a second were pretty bad for accuracy.
Not enough information.
Right, but medium duration, say between 1 and 3 seconds, that seemed to be the sweet spot. Optimal efficiency, you get good accuracy without needing a long sample.
And longer clips.
Longer clips, over 3 seconds, gave the best accuracy, but the improvement started to level off, diminishing returns. So that 1 to 3 second range seems practical for many uses.
Good to know. Any other unexpected findings? Biases, maybe?
Yes, and this one is really important. They found a significant gender performance disparity.
Yeah, how so?
Their analysis showed that male speakers consistently had substantially lower emotion recognition accuracy across all the emotions they tested, especially for surprise and sad.
Lower accuracy for male voices.
Considerably lower. In contrast, female speakers in their data set achieved noticeably higher accuracy for most emotions.
Wow. Why would that be?
Well, the paper suggests it might reflect biases present in the training data itself, or perhaps differences in emotional expression norms, but whatever the reason, it's a really critical finding.
Yeah, it highlights a potential issue with fairness or representation in the data or model.
Exactly. It's a reminder that these systems learn from the data we give them, biases and all. It points to a need for more balanced data and careful consideration of these disparities going forward.
Absolutely. So pulling it all together then, what's the big takeaway here? How does this unified Markov voice approach really change the game for speech synthesis? What does it mean for, us?
Well, connecting it back, that unified modeling approach really seems to be the key innovation. It allows Markov voice to learn that intricate dance between who is speaking and how they are feeling together.
Instead of treating them separately.
Right. And that leads to, as the results suggest, much more natural, much more consistent, and more emotionally authentic speech. It's a big step beyond just making voices sound clear towards making them sound real and alive.
Capturing more of that human nuance.
Exactly. What Markov voice seems to unlock is a higher level of emotional authenticity in AI voices. And that's not just about sounding nice. It could be about building more trust, more connection in human-AI interaction, moving AI beyond just intelligence toward, well, maybe a bit more resonance.
That is a powerful idea. So where do the researchers themselves see this heading? And what limitations do they acknowledge? Because no tech is perfect, right?
Oh, they're very upfront about the limitations. Firstly, the model, even this advanced version, still relies heavily on that paired emotional speech data, needing examples of the same speaker saying things with different emotions.
Which is hard to get, as we discussed.
Exactly. It's scarce, especially for many languages and specific speaking styles. That remains a bottleneck. Second, computational efficiency. Making this run smoothly in real time, say, on your phone, that's still a challenge. It's pretty computationally intensive.
Not quite ready for instant generation everywhere yet.
Not quite at massive scale, no. So for future work, they're looking at things like semi-supervised learning, trying to reduce that dependency on perfectly paired data.
Using data that isn't perfectly labeled?
Right. Also, model compression techniques to make it faster and more efficient. And of course, expanding language support beyond just Mandarin and English.
Lots still to do, but a clear path forward. Well, this has been a really fascinating deep dive into the world of emotional AI voices. Markov voice genuinely seems to be pushing the boundaries,
It really does.
bringing us closer to that future where AI voices aren't just functional, but genuinely expressive, relatable, human-like.
It's exciting to think about the possibilities, isn't it? How this could change virtual assistants, making them feel more empathetic, perhaps?
Or content creation.
Yeah.
Imagine audiobooks where the narrator perfectly captures every emotional shift.
Yeah, making our interactions with AI potentially feel much more natural, maybe even more meaningful. That ability to disentangle identity and emotion and control emotions smoothly, it opens up a lot of doors.
Absolutely. It's incredible to see AI tackling something so fundamentally human as emotional expression through voice.
A really interesting space to watch.
And that wraps up our deep dive into Markov voice for today. We hope this gave you a good sense of where this cutting-edge tech is heading. If you found this as fascinating as we did, definitely hit like and subscribe if you like the content.
Yeah, let us know what you think, too.
We'll see you next time.